Yes, class. Is it audible to all of you? Rishan, Atif, Hamza, Hanifa. Audible?
Yes.
All right. So who all have joined? Zefa, Sarah, Zen. Atif and Sarah, are you both available on Monday, Wednesday? 9 p.m. will be. How much will be 9 p.m. according to you? 9 p.m. IST. The batch in which you were earlier, both of you. Are you available at that timing? Just let me know. All right, let me know at the end of class. Text me on the chat box. So that means 7:30, I believe. 7:30 KSA timings. Both of you, Atif and Sarah. 8:30 to 10. Okay, 8:30 to 10 you have the classes. And 9 to 11 is the class. No, okay, Sarah. Chemistry classes are there on Monday. Okay. Okay, and one more thing. I wanted to ask you. Another Sarah is there, na? Sarah Parkars. Are you free on Monday, Wednesday, 5:30 to 7 KSA? And Saturday, Sunday, 6 to 7:30 KSA? Because in those classes, we are starting from fresh. From chapter 1, Monday, Wednesday, first book will be covered. From Saturday, others also who want to shift their batch, those also. Like Zen also has joined in the middle. So if Zen also wants, Zen can also. But Sarah has joined, I think, in the month of November only. So that's why I wanted to ask. Monday, Wednesday, 5:30 to 7 KSA. That is 8 to 9:30. You will be having Atif for Monday, Wednesday, you are available. Okay. So on Monday and Wednesdays, 5:30 to 7, that is 8 to 9:30 IST, your first book will be covered. And on Saturday, Sunday, 6 p.m. to 7:30, your second book will be covered. So I think students who have joined recently, those who have not attended all the classes, like most of you have attended the classes from the beginning, but those of you who have not attended the classes, even Rishan to you, because Rishan, you have missed so many classes because of traveling and all. Hanifa also joined in the middle, but I think Hanifa has covered many chapters with me. Some chapters only were missing. So Sarah and Zen, especially to you both, if you are available, you can shift your batch, especially Sarah, because from there, totally from the beginning, detailed revision will be done. Crash courses, batches are there for board examination. So complete revision starting from first book and second book simultaneously, it will be covered in detail. So if you're available in these timings, if you want, I'll type you the timings in the chat column. Let me know, because I think that will be beneficial for you. Here we'll be doing the revision at a more steady pace. In those batches of crash courses, which I was mentioning you right now, there the syllabus will be covered a little at slower pace. And especially these are for those who have not attended the classes. So Sarah can shift the batch, Sarah Parka. And Zen also, if Zen is available. But I think Zen, you have covered the second book with me. Zen? First book, I think you didn't. From Ray Optics, I think you were present. Second book you have covered. No, the first book you bacha hai. First you need to. And Sarah, let me know about these timings. And if you want, I will write down these timings. So Zen, you can also, if you want, Monday and Wednesday, you can join one batch where your first book will be covered. And second book, you can do it with me as per it is going. So It's open for anybody who wants to shift their batch. But for other students like Huzaifa, Hiba, Hamza, Atif, they have attended all the classes, almost all the classes. I think 1 or 2 classes only have been, especially Hiba. I don't even remember when she has taken leave. Hiba, Huzaifa, Hamza, Atif, you all are very regular. Even Sarah. Sarah has also attended all the classes. Hanifa, I think, has joined in between. Rishan has missed a lot of classes. Atif, if you are available, then I'll suggest you Monday and Wednesday. Okay. You have chemistry class on 6 p.m. KSA. Let me just see it then. Monday, Wednesday. Okay, 6 p.m. No? Then I'm telling the timings again. For the first book of physics, all of you listen. Monday and Wednesday, first book will be covered 8 to 9:30 p.m. IST. That means for you people, it will be 5:30 to 7 p.m. KSA timings, 1.5 hour class. Then on the weekends, Saturdays and Sundays, you will be having classes with me. That is second book. I'll be starting with second book only. So 8:30 to 10 IST, that makes it 6 p.m. to 7:30 KSA timings. So 5:30 to 7 KSA on Monday, Wednesday, book 1, 6 to 7:30 KSA on Saturdays and Sundays. So by this, you will be able to complete the entire lesson. Or if you want, like Zen's first book is missing. So you can join Monday and Wednesday, that part. And then for weekends, you can just keep on joining. Just let me know. I hope all of you have heard the timings. Monday and Wednesday, you have chemistry class. No, okay, Sarah. Then Monday, Wednesday. And what about Saturdays and Sundays, Sarah? 8:30 to 10 means 6 to 7:30 for the KSA timings. 6 to 7:30, Saturdays and Sundays. Sarah Parkar. You are free on Saturdays and Sundays. Okay, then I think second book will be covered there, so that will be better. Okay, thank you then, Sarah. I'll let you know then. I just wanted to know about your timings, about your batches, and when are you all available. And Atif, Monday, Wednesday, 9 to 11 IST. 9 means 7:30, no? No.
Yes, ma'am.
7:30, no? So 7:30 to 8 to 9:30 for you. The earlier batch in which you were. If you are available, I think you should join that batch. For Sarah, I understand Sarah, the other Sarah has her chemistry class. Otherwise, Sarah, I would suggest Sarah also, she could have joined that batch Monday and Wednesday. But Atif, for sure, you have to change your batch. Okay, that will benefit for your revision classes. Fine, Atif.
Yes, ma'am.
Then Tuesday and Thursdays, you will be free. So Tuesday, Thursdays, whatever schedule you have, I hope you're available. Otherwise, I'll tie up the timings and all. Rest of you, we'll start the revision from here only. Okay, so students like Sarah and Atif. Sarah, I'll just see if the timings could be changed. You have your timings. What was the timing that you mentioned? 8:30 to 10 p.m. This is Sarah IST timing. No, you're in India, I think. So IST timing, no, 8:30 to 10 p.m. Okay, so 8:30 to 10 you have chemistry class on Monday and Wednesday. Okay. Atif will join Atif will change his batch. Josefa, Sarah. Then Sarah, I'll let you know. Other Sarah Parkar. And Zain, what about you? Available or not? Out of all the days that I've mentioned. Available, no? Okay. So then on all the days, Monday, Wednesday, Saturday, Sunday, the timings that I mentioned, not Saturday. Saturday, 6 to 7:30 KSA, no, not available. Okay. ठीक है, but Monday and Wednesday you are available from 8 to 9:30. Okay, you have your maths class. ठीक है then. ठीक है. Now I just wanted to know these things because I couldn't discuss it with you last weekend. No, Atif, they have started. Yesterday we had the class, but it was actually, the merging was to occur in opposite manner. Some students had to join this batch, but that was not possible because of their chemistry classes. So it's better if you and some of the students of this batch join that I'll text you. I'll text you right now, not next week, tomorrow, Wednesday, join it. Current electricity we are going to do, Atif. Revise current electricity and come. It will be beneficial for you because in those classes we'll be covering smaller portion of theory quickly. We'll be revising it and we'll be jumping on to numericals. Those types of numericals we have not done in the class and have come in the previous years. Okay, Atif. So join it from tomorrow. The rest of the things I'll just text you the timings and all once again. Okay. Yes, class. So just attend today's class also, Atif. And I'll share one video also with you. So yes, class, let's start with electric field and charges. So this is your chapter 1, electric charges and field. So under electrostatics, what all things you have to remember. Now class, please have a habit of unmuting yourself because these are not now your regular classes that I have to complete on the syllabus. We are doing revision classes. Revision is being done. So if you have a habit of unmuting yourself and then answering, then only the revision is going to benefit you. Because I'll be asking you the things that I have revised with you. And then we are going to repeat it. A portion we'll discuss, a portion we'll study together. We'll revise it, then we'll move on to numericals. And all the numericals will be from your previous year questions of CBSE. And in these revision classes, I'll be strictly sticking to your CBSE syllabus only. Everything will be just related to your board examination. So sometimes I tell things like, this is going to come in your entrance and all those things. Now I'm not going to mention. Strictly, we are going to stick on CBSE syllabus. So revision classes are going to benefit you if you revise it simultaneously. And rest of the students who I wanted to know about the timings of class and all that, I'll let you know which batches will be suitable. I just wanted to know about your availabilities. And class, one more thing. All the numericals that we have done in the class already, and other students also, those who didn't attend it with me, like Zen, Hanifa, and all the first chapters, you all didn't do it with me. So I have shared all the OneNote link drive. So whenever you are revising, let's say first chapter you are revising. So if you wish, you can escape the theory part, but at least practice the numericals from there. Most of the question papers that I have taken from all of you and had all the questions that we had discussed in the class only. So our class notes questions are so much that if you practice that one, that will also going to benefit you. And then on addition to it, practice the numericals that are coming. And when I'll ask questions, do not run away, do not get scared. Answer it, try to learn it in the class only. So yes, under electric charges and field, and yes, I'll be mentioning throughout what all topics are important, what I have the chances are likely to come in the exam and all. If you wish, you can keep on noting that in your notebook. Now from the first topic, that is electric charge. Electric charge, under electric charge, specific definition cannot come. Electric charge, we all know, it's the intrinsic property of matter. SI unit, you have to remember Coulomb, because SI unit will not be asked to you, but it has application, and you know, till the end, semiconductors, you had seen Coulomb coming. Electrostat Coulomb is the CGS unit of it. So under electric charge, those things you do not have to remember. Mainly you have to remember is that electric charge is 1.6 into 10 to the power minus 19 coulombs. Plus minus 1.6 into 10 to the power minus 19 coulombs. Fine. This value of charge you should remember. And class, we had discussed it. Whatever we have discussed in the class, that only I'm repeating. So an object comprises of electron, an object comprises of proton. But since these electrons are weakly bonded, and they are held through weak electrostatic forces of attraction. While what happens to the nuclear forces? Nuclear forces, they are held tightly. Nuclear forces are held tightly with the help of nuclear forces. These protons are held tightly with the help of nuclear forces. So nuclear forces do not allow the protons to move out of the shell, while electrons, since they are held weakly through electrostatic forces of attraction, they are more likely to move out of the atom. So this concludes what? That it's the transfer of electrons that occur. So the second important thing after 1.6 into 10 to the power minus 19 coulomb is that transfer of electrons occur. It's not the transfer of protons that are occurring. Questions have not come from this topic like all these questions, but they have application when you come to the process of charging. Charging term will be used or transferring term will be used. If charging is used in your electrostatics, just understand charging means that electrons have transferred. So transfer of the electrons is known as charging. So body is charged means electrons have transferred. Now electron will be having its own mass. Mass of electron 9.1 into 10 to the power minus 31 kgs. Fine, this is the mass of electron. So if 5 electrons have moved out of an atom, it means 5 times the mass of electrons have moved out. So if so much electron mass has moved out of the shell, making the electron positive, mass of the entire atom will decrease. Opposite happens to negatively charged electron. What happens in negatively charged electron? Electrons come from the other shells. Electrons come from other atoms. This results in net gain of electron, and also the mass of the electron also increases. The mass of the electron also, mass of the atom increases. Reason? Because each electron has its associated mass with it. Fine. So charging means transfer of electrons. Body, negatively charged body means body that has gained electron and the mass also increases. Positively charged body means body has lost electrons and the mass decreases. Depending on this, now how to transfer electrons? Can we just keep the body in contact? Can the two bodies should be rubbed against each other? What should be? So those are known as methods of charging. When you come to methods of charging, you have three methods of charging. Now class, from here, charging by friction, charging by conduction, charging by induction, set types of questions have come in your exams that I'll keep on mentioning to you. Charging by friction simply means mere rubbing of two objects. When two objects are rubbed together, electrons get transferred. Electrons are transferred. So positively charged body loses the electron, its mass decreases, and the negatively charged body gains the electron and its mass increases. This is regarding friction. Now, what type of questions come in your board examination? These are based on bounded. How strongly an electron is bounded, how weakly an electron is bounded. If I say, I'll show you. Here. If I say in B, electrons are strongly bonded. So electrons are strongly bonded. It means it is difficult to remove it. And if it is difficult to remove it, that means it will not allow the electrons to move out, resulting in increment in the electron. So by this, you have to identify whether a body is positive, negative. Just the gist of the entire discussion of the first topic of this lesson is that electrons are the entities that help in transfer. They are the entities that get transferred from positively charged body to negatively charged body, basically making a body positively charged and entering into a body and then making it negatively charged. So depending on this, the type of questions that can come will be the way we have done. A is positive, B is negative. Such types of questions only. Now, these are by convention: glass rod positive, silk negative, wool positive, plastic negative. These are by convention. You have to remember these. These two can be asked to you, class. These two values. Specifically, we have done these two values only. The reason was this one. So, glass rod, silk, positive and negative. Then charging by conduction. When an uncharged body is placed in contact with a charged body, it gets charged due to the transfer of electrons. It means when two bodies are kept in contact, now you are not rubbing it. Not rubbing is the key term that you have to remember that will help you to distinguish between the conduction process and the friction process. Fine, class. This is the way you have to differentiate between it. So when they are just placed in contact, total charge gets distributed equally if the bodies are identical. And class, maximum chances are there that in your examination, you will get these identical bodies only. Why will you get these identical bodies? Because, and one more thing, when identical bodies are asked, all the charges will get equally transferred. Now, if one person has irregular number of chocolates, other person has a irregular number of chocolates, and you want to divide the entire chocolate between both of you equally. So what will you do? First, you will collect all the chocolates and then divide it by 2. So same thing here also. One body has one type of charge, another body has another type of charge. To divide it equally between two bodies, you will do what? You will add all the charges and then divide it by 2. So this is charging by conduction, and questions come from this part only. Identical bodies will be given to you. Non-identical bodies are not given usually in the examination. Then in charging by induction, you have positive and negative charges together, making the object neutral. If you want to isolate negative charge or isolate positive charge, the best method is bring up a charge that will bring up a rod that consists of one type of charge that will attract one charge and it will segregate the other one. Now whatever function you have to perform, it will. Now what type of questions can come from charging by induction? From charging by induction, you have those types of questions. Make an isolated sphere as negative or positive, like this question. So make this isolated sphere as positively charged. So we brought a negatively charged rod, attracted all the positive ions, and negative electrons were on the opposite side. When you earthed it, potential became 0. That means it neutralized all the electrons. All the electrons ran away into Earth. That is what is meant by earthing. Electrons run away into Earth. So when the electrons move, all the positive charges are now left. So when you bring the rod or move the rod back, all the positive charges redistribute among themselves. Rishan, your mic is on. Okay. Now, 3 properties that you have to remember is additive nature of charge. Now, additive nature means you can directly easily add, subtract all the charges. Then you have conservation of charges. Conservation of charge means whatever charge was present in one body, that will only get transferred to another. Total charge will remain the same. If 3 electrons have transferred, total charge will remain the same, and number of transfer of electron will be definite. It will not be lost anywhere. It will just be transferred from one body to another. Invariance of charge means it is independent of the speed. Like if you are having a metal conductor is having large number of electrons, and you increase the speed of the electron, value of electronic charge will still be 1.6 into 10 to the power minus 19 coulombs for any type of charge that is available. So conservation of charge, invariance of charge, the most important property is quantization of charge. From quantization of charge, this can come Q is equal to NE. Number integral, N is any number of electrons that are present, E is electronic charge. And Q is equal to NE. If it is not directly asked to you, some questions will be there which will use this concept. Q is equal to NE. Fine. Q is equal to NE will be used, and you have such type of question that we discussed in the class. So what all topics we have done? From here, electric charge, Coulomb SI unit, amount of charge that it holds, is the transfer of electrons that occurs because these are weakly held through electric forces, while nuclear forces hold the protons together. In charging, you have from when a body loses its electron, its mass decreases, and it's the deficiency of electrons that makes a body positive, while the body that gains the electrons, having its mass also increased from the initial atomic mass, is known as negatively charged body. Then three types we have seen: charging by friction, charging by conduction, charging by induction. Friction was direct rubbing, conduction was placing in contact, and induction was bringing another charged particle. And then four properties we had seen: quantization of charge, additive nature, conservation of charge, and invariance of charge. Is it clear till here to all of you?
Yes, ma'am.
Okay. Now coming to this law, Coulombs law. So Coulombs law is a simple law. Questions will come from Coulombs law. Coulombs law is an important topic. Now, if Coulombs law is asked to you, you will mention the statement that according to Coulombs law, electric force between 2-point charges is directly proportional to the magnet product of magnitude between them and inversely proportional to the square of distance between them. That makes the formula F is equal to K Q1 Q2 by R square, and K is 9 into 10 to the power 9. This is the formula of force value of the constant that is present. Now, one quantity that is present is absolute permittivity epsilon naught. What becomes confusing here is what is K. So K is also ratio of epsilon by epsilon naught. Epsilon naught's value, all of you should remember, 8.85 into 10 to the power minus 12. This is the value of absolute permittivity of air or vacuum. Wherever you will see epsilon naught, you will keep on these values by yourself. So absolute permittivity of free space or air. F is equal to Q1, Q2 by R square. All right. K is the constant, 9 into 10 to the power 9. So K, Q1, Q2 by R square. If the law is asked, directly write it is proportional to product of magnitude of the charges and inversely proportional to square of distance between them. If you see it's a question that is comprising of 3 marks, then don't just leave it till here. Add all these properties, write down the properties. Means it is valid for spheres or positive charges. And it is valid if the charges are static or at least one of them is at rest. If both the charges are in motion, then you cannot apply Coulombs law. It's a conservative force and central force, centrally acting force. Is it? This is Coulombs law. Yes, this part I was saying. What becomes confusing at the end is whether it was epsilon by epsilon naught or epsilon naught by epsilon. So please be precise and clear that K is epsilon by epsilon naught, especially students who are having their investigatory projects on this or who will be getting their experiments from this. This question is asked a lot in Vivas also, whether K's ratio was epsilon naught by epsilon or epsilon by epsilon naught. And it becomes opposite when you talk about force. Forces, K will be equal to force in air by force in medium, but epsilon will be up and epsilon naught will be in the denominator. Let's see one question from here. Note it down, class.
Done, ma'am.
See class, it says that a charge Q is to be divided on two objects. What should be the values of the charges on the two objects so that the force between the objects can be maximum? So you will apply Coulombs law here. See, this is Q. Q has to be divided between two objects. This has to be equally divided between two objects. If one part is X, or let's say small q, other part will be capital Q minus small q. Total is, let's say this part is some X, this part is Y. So X plus Y will be Q. So X will be Q minus Y. So similarly, this X is Q minus Y or Q minus small q. Now apply Coulombs law. When you apply Coulombs law, it is K, Q1 first Q, second Q. So Q into Q minus Q by R square. See class, whenever it is said, no, when the force between is maximum, force between maximum, this means that force with respect to charge is zero. Whenever. So in any question, if you get force maximum, then it means dF over dQ is zero. All right, dF over dQ is zero. Now see, so here if you see K, then you differentiate this with respect to charge. This will be K. Then D, you are differentiating, multiply Q within the brackets. And you will be having here dQ and 1 R square will also be there. This will be equal to 0. So rest of the terms will be 0. You will just be left with this term. These two terms will be 0. So you will be left with Q into capital Q into minus Q square. Differentiating with dq is 0. Now see, small q into capital Q when you are differentiating this term. Small q is constant, capital Q is constant, and q square means 2q. This is 0. So capital Q is 2 small q. Small q is equal to capital Q by 2. It means one part is q by 2. So other part will obviously, again, it will be q by 2. This is how the charge is. Just remember one thing here. This is important step. Note down the solution.
Done, ma'am.
Coming to electric field. Electric field is what? Electric field is basically space around a charge where you can experience electric force. Now see, in electric field, around the source charge, you have space, but the charge that you bring up, that is known as test charge. So source charge produces electric field and the test charge experiences the force. Now see, this space is known as electric field. Space around the charge is known as electric field. So if you bring a test charge, the source charge will experience the electric field. Now see, when electric field is asked to you in the theory part, you have to mention the definition of it. Then you have to mention the formula for it, that it is force per unit charge. Force per unit charge you will have to mention. And then you will have to mention this electric field, limit Q is 10 to 0, F by Q. Fine. So electric field is a vector quantity, means you will be requiring vector forces. Parallelogram law you will use, triangle law you will use, polygon law you will use. So that is what you have to write in electric field. Vector quantity, SI unit you should remember. Now, yes, electric field for point charge is more important. So formula for electric field for point charge becomes KQ by R square. This derivation can be asked to you. So if you compare all these three, force, I have not written it somewhere. Okay, anyway, see, electric field is KQ by R square. Coulombs forces, electric forces, KQ square by R square. See here. Electric forces, KQ square by R square. Electric field is KQ by R square. This is the difference. And when we'll do potential, you will notice it is KQ by R only. So by this, you can remember the basic formula. Then you have to remember the direction. For electric field, you move towards the charge. For positive charge, you move towards the charge. For negative charge, you move away from the charge. Let's practice some question. Now class, continuous charge distribution is there. We'll do continuous charge distribution first. Then I think a combination of question will work. See, linear charge density means charge per unit length. Whatever charge is present per unit length. That means Coulomb per meter is the SI unit of it. Then you have superficial charge distribution. It means charge distributed over an area. So charge per unit area, charge divided by the area. So if it's a sphere, it will be charged by 4 pi r square. If it's a cube, it will be a cube, like this, charge per unit area. Then you have volumic charge distribution. So superficial term can also be used, or volumic, superficial or surface, both can be used. Now volume charge distribution will have volume charge density, that is charge per unit volume. So continuous charge distribution, this is Gauss-Law, we'll come back to this. So from here, let us practice one question. From this continuous charge distribution. Note it down. And send the answers of this question. See class, this says that a charged spherical conductor has a surface density of 0.7 coulomb per meter square. So surface density means surface charge density. That is charge per unit area, and sphere is there. So area will be 4 pi r square. Now see, it says, so surface charge density is given 0.7 q by 4 pi r square. This is the first equation. In the second case, it says when its charge is increased by 0.44 coulombs. It means now the charge will be charge plus 0.44 coulombs. Then the charge density changes by 0.14. It means 0.7 was already there, plus you will now have 0.14 divided by 4 pi r square. This is second equation. Now you have two equations. Use both these equations. So this will be 0.84 q plus 0.44 divided by 4 pi r square. So if you take the ratio, this will be 0.84 by 0.7. See, 4 pi r square will get cancelled. So q plus 0.44 by q, that is 6 by 5 is equal to 1 plus 0.44 by q. When you will solve this, you will get the charge around 2.2 coulomb. And you also had to find out the radius. Now you can find out the radius using any of these equations. Now you know the value of charge. 4, pi, using that you can calculate the value of radius. So radius will be under root q by sigma 4 pi. Just exchanging sigma and r. So q is 2.2, sigma is 0.7, 4 into 22 by 7. So this cancels, these get cancelled 1 by 2, that is 0.5 meters. So radius is 0.5 meters. Noted down. C class, superposition principle basically means what? Whatever amount of charges that you have, whatever amount of charges, be more than one. Two charges are present, it will be having its own electric field, specific electric field will be present. Every charge will be having its own electric field, every charge will be having its own electric force. So if this is the case, then net electric field, net force will be given by the vector sum of all the charges of the individual electric fields and electric forces. 5 charges are present, 5 forces will be there. If 5 forces are there, all the forces will be added vectorically. Vectorically, whenever I use the term vectorically, it means using vector laws. All the vector specific laws you had. Triangle law, polygon law, parallelogram law is the most common. So superposition principle had this part only. Whatever is the net field like this. And one more thing, class, for symmetrical figures like center of circle and all, you have electric field 0 at the center. Fine. So notes have sufficient questions from this part. Like this, these are symmetrical figures. So at the center, electric field will be 0. Coming to dipole moment. C class, monopole's definition and monopole moment will not come in the exam. Dipole moment is necessary, that these are two, you have to mention that these are two oppositely charged charges having same magnitude but they are having opposite signs. They are separated by smaller separation. Then you'll also have to mention the amount of electric dipole, how to calculate it. So calculation direction is very important. So how to write it? Charge multiplied by the separation between the two charges. This is electric dipole. So Q into 2A vector quantity direction is from the negative to the positive charge and SI unit is Coulomb meter. This part you have to understand. Now electric field on the axial and equatorial line. These derivations can be asked to you in the class. Now see, if radius and the separation between both the charges are comparable, then use this formula 2 kpr by r square minus a square to the power whole square. If you see both are not comparable, like radius is very huge or greater than the separation between the charges, then you can approximate, use ideal dipole approximation and write 2 kp by r cube. Both are valid, but 2 kp by r cube will be used only when your a is missing. If only one value is given, then use 2 kp by r cube. This was axial, same for equatorial. Equatorial's definition, derivation has also come a lot in the exam. So these are the formula. This one is kp by r square plus a square to the power 3 by 2. When you approximate it, that becomes minus kp by r cube. Both of these are important. And yes, this relation is asked a lot in the exam in very easy questions of yours. Axial and equatorial electric fields relation. So that time you just not have to mention this line. You have to mention this. You have to show how you have got it twice. Fine, like this you have to show it. Then these basic questions we did. Some questions do it right now on dipole moment. A dipole moment and torque also. Let us complete torque because dipole moment and torque questions are usually simultaneously asked in your exam. So when torque is asked to you, before torque, see class. This involves simple kinematics, charged particle in an external electric field. Simple kinematics, all the equation of kinematics that you have to use. But come to here first, torque, yes. Whenever torque is asked to you in the exam, nobody is going to start the derivation from here. Though this is the derivation, you are not going to start the derivation from here. You will have to first mention that net force on the dipole is 0. That is plus Q cancels minus Q. Plus Q minus Q is equal to 0. Net force on dipole is 0. You have to mention it. Then you will begin. The torque will be R cross F, and when you perform the derivation, you will get P cross E or PE sine theta. And direction of torque will be dipole will try to rotate it and align it with the electric field. Rest of the things, yes, class, this part, great. Here. This is asked to you, and the special cases are asked to you separately. In your conceptual questions that you have, short conceptual questions like dipole is parallel to electric field, dipole moment when is 0 means when it is parallel to electric field. What happens to which type of equilibrium it is, stable equilibrium, unstable equilibrium, like this. If it is anti-parallel, then what happens? Condition of unstable equilibrium. If it is perpendicular, likewise, you have to remember the torque will be maximum. So it can be directly asked to you, when can the torque be maximum? When can the torque be minimum? When it is minimum with stable equilibrium. So these special cases can be asked to you, these special cases which are mentioned. Fine, rest of the things I think we had covered it only. Now let us practice some questions. No, Atif. Check the answer once again. No, Sarah. You also check your calculations once again. No, Atif. You have just added meter into the SI unit, not just because of SI unit. Last 2 minutes class, others also respond apart from Atif and Sarah. Rishan, Hamza, Hanifa, Hiba, Huzefa, Zen. Now it's correct, Sarah. Now I'm discussing it. See, this says that an electric dipole consists of two opposite charges of magnitude 1 by 3 into 10 to the power minus 7 coulomb. This is the charge given to you. These are separated by 2 centimeters. Separated by 2 centimeters means distance between that is 2a. Is 2 into 10 to the power minus 2 meters. Charge is 1 by 3 into 10 to the power minus 7. What maximum torque does the electric field exert on the dipole? See, electric field is given to you as 3 into 10 to the power 7 Newton per coulomb. Torque will be PE sine theta. Maximum torque. Maximum torque case is PE because sine 90 will be 1. Now, P will be 2A into Q into E. So 2A will be 2 into 10 to the power minus 2. Charge will be 1 by 3 into 10 to the power minus 7. Electric field will be 10 to the power 7, 3. So 3 will get cancelled. 10 to the power minus 7 plus 10 to the power 7 will get cancelled. What will you are left? What are you left with? Torque is 0.02 Newton meters. Now, next is electric field lines. So, electric field lines are geometrical representation, not geometrical, geometrical and pictorial representation mainly of electric field. So, these are curves that are tangent to the direction of electric field. Now, see, whenever the question is from electric field, always remember from electric field lines, sorry, not electric field lines, you have to mention the definition, but without writing the properties, it will be incomplete. And from some of the properties, it will be asked to you separately. All right. Now, see, first is that these are tangent to the electric field. Fine, that gives the direction of electric field. Electric field lines, these are the tangent basically. They cannot intersect, and wherever they are located closer to each other, that depicts stronger electric field. Wherever they are located farther from each other, that indicates weaker electric field. And this point, class, third point is very important. This third point can be asked separately to you also. This question can be asked separately. Identification questions can also be asked, like a positive charge will be made and you'll be asked to draw the electric field lines for the corresponding charge. For isolated negative charge also it can be asked to you, and for a combination of positive negative, that is dipole, it can also be asked to you. So be prepared for the dipole as well. Dipole can also be asked. Then they are continuous curves, and this point is not very important, contract longitudinally. So electric field lines contract longitudinally means they're showing the attraction between them. And then they exert lateral pressure on each other. Explain. They exert lateral pressure on each other. Fine, basically showing repulsion of charges. Now they cannot, neutral point from neutral point, the questions will be electric field lines that are located near it or parallel it. So from neutral point, you do not have separate questions from neutral point, but neutral points questions are there, like calculate electric field, calculate the neutral point where electric field is 0 or force is 0, like this. And electric fields cannot penetrate a conductor, means they are perpendicular to the surface. So these properties you have to mention when you write about the electric field lines. I'm repeating. Firstly, they are tangent and cannot cross each other. Wherever they are located closer, depicts stronger electric field. Wherever they are located far apart, it depicts weaker electric field. Then electric field lines originate from positive charge, terminate at the negative charge. For positive charges, it moves away from the charge. For negative charges, it moves towards the charge. They are continuous curves, no breakage in them. And from positive to negative, it will move, but they exert lateral pressure on each other, which shows repulsion, and longitudinal pressure, which shows longitudinal compression, that shows attraction between them. Neutral point also I've discussed. Neutral point is the point where electric field or the electric force also cannot pass through that particular point. And on the conductor, these lines will always be perpendicular to it. Then this is the most important topic, electric flux. From electric flux, you have plenty of questions. All those students who have not practiced the class notes yet, please, you all have the drive link on WhatsApp. Practice it. Now, electric flux is what number of field lines that is crossing an area perpendicularly or normally. That is what is meant by electric flux. So phi is equal to E dot S, dot product of electric field and surface area, or ES cos theta. It's a scalar quantity, and main important thing is area vector. Area vector will always be perpendicular to the plane surface. It seems like area vector, as in some questions it appears that the angle is made between the plane of the surface and area vector. Class, whenever any other angle is given to you, you have to take out, drop area vector by yourself and check whether the angle that is mentioned to you is actually the angle between the area vector and the electric field or not. If it is not, then you have to calculate it by yourself. Otherwise, do not use it directly. For curved plane surfaces, we have now coming to this main thing, Gauss theorem. Whenever you have Gauss theorem, whenever you're studying electrostatics, the most important topic from electrostatics is Gauss law. So Gauss law basically says that this E dot ds is clear, integrally of E dot ds. Gauss law says that the total charge that is enclosed within is 1 by ln naught f, the total flux that is enclosed by a charge, total electric flux that exists is 1 by epsilon naught times the charge that it has enclosed. So Q by epsilon naught is the Gauss theorem. Now class, if it is for a 1 marker, then writing this definition is sufficient. If it's for more than 1 marks, then you have to add on the properties along with it. Flux is independent of shape and size. Total flux, these can be added also. You have to take up the enclosed charge. Outward flux will be positive, negative flux will be negative because of charges only. And if electric field, somehow your angle is 90 degree. And so flux becomes 0 if your theta becomes 90 degree. All right, and net force on a dipole becomes, net charge of dipole becomes 0. So flux automatically becomes 0. This is what you have to remember. And then applications of Gauss law. These derivations come in different set, different objects will be given. Like in set A, infinitely long wire will be given. In another set, you will be having a different quantity like this. So electric field due to infinitely long wire. So formula for it is 2k by f2k lambda by epsilon naught, or you can simply say lambda by 2 pi r epsilon naught. Then electric field due to infinite plane sheet, flux is Q, electric field is sigma by 2 epsilon naught. If it is for 2 sheets, then it gets added and that becomes sigma by epsilon naught by adding it. Fine. And finally, when you are talking about spheres, so it is sigma Q by epsilon naught is the flux, no? And if you write the value of sigma as Q by 4 pi r square, that will help. So E by epsilon naught, and E inside is 0 for a hollow conductor. So for solid conductor, value of electric field will be 4 pi r square only, or you can use this formula also, sigma r square by epsilon naught small r square. Then exactly at the surface, you will just put small r as the radius now. And when it is inside, electric field inside a hollow sphere is 0. Now let us practice some questions. Then we'll complete with this lesson. Not magnetics. Write down this question. Class, answer the first part at least. What is the ratio of electric flux through S1 and S2? No, Zen, not R1 by R2. Specific value you will get as the answer. Others also send their answers. Only Hamza and Zain have answered. Others, last 2 minutes, then I'll discuss it. So correct answers have been given by Hiba, Hanifa, and Hamza. Others, C class, you are not taking the total charge enclosed. For the first part, see here. Flux through the first sphere S1. This will be simply Q by epsilon naught. But flux through second sphere will be Q plus 2Q by epsilon naught. No, you take the total charge enclosed by S2. S2 is having 2Q, but it is enclosing Q also. So total charge will be 3Q. Now take their ratios. Phi 1 by phi 2 will be 1:1 by 3, 1:3. If you take the ratio of through S1 and S2. All right, because rest of the things will get cancelled. Q by epsilon naught will be there and 3Q by epsilon naught. Rest of the things will get cancelled. This will be the answer. For the second part, see, some different flux is there where dielectric constant has been introduced. This different flux, this is actually equal to E dot ds. Let's say E dash. Closed integral of E dash. E dash will be E by K. So now see, the new flux will be what? The new flux will be E by K ds. So see, E dot ds is again your flux, initial flux you had. That is Q by epsilon naught. And this is K here. So this will be the answer. And C class, flux through S1 does not change with the introduction of dielectric medium inside the sphere S2. So this is for second part. Note down the solution. Text me when you are done, class. all those who are completed, you can leave because maximum portion of this chapter has been over. For the next class, you will be informed about, you join the class, you will be getting reminders, but students know who I have mentioned the names, Atif, Sarah, Zen and all, you will be informed about the classes, rest of the classes that will start.